Hello everyone, welcome back to Sun Innovative YouTube channel. So till now I think you have understood that what is the today title. So today's title is Park and Clark Theory example with the nonlinear load, and this simulation will show you the alpha, beta and the dq transformation from the three phase as the today title. So the simulation will show you that how to use the alpha, beta and ABC to transform, which is useful for our controlling purpose. So mainly basic Park and Clark transformation is actually it is to simplify the controlling system which is available in an industrial product and industrial equipment, so that you can control your waveform and the voltage and current in such a manner that it will become the fast process and the accurate controlling parameters. So this is very important that you can control your wall system three phase into the two phase system. So it is become very much popular nowadays. So here you can see this is the non-linear load, actually three phase source, and it is connected with the measurement, and this is the line impedance, and this is non-linear load, and this is the RL inductive load. And from this measurement the signals is gives VABC and IABC, three phase ground current and voltage. So that signals is directly transmitted over here. This is the VABC and IABC current and voltage signals from the non-linear load, and it is goes to the ABC to alpha beta transformation. This block you can get from the Simulink library browser like this: alpha beta, or you can write alpha beta transformation. So you can see here ABC to alpha beta 0, and this blocks is used to design your simulation like this way. So this connected with the demux over here, because we need to separate these values from the alpha beta. So this blocks is shows the only the matrix. You can see this is the matrix, and you can see in window also that how the matrix is used to convert the three phase power system to the two phase. And here you can see the voltage signals is converted to the two phase, and here the current signals is converted to the two phase, and scope is connected for the three phase ABC, and here the alpha beta. And next is the PQ calculation. So this is the important term which is used to calculate the instantaneous power of the nonlinear load, because as we know that once your nonlinear load is connected to the power source, so it produces the harmonics current in a neutral. So it is a tough task that each and every important point of the instantaneous power, so that kind of points are required to be measured accurate and precise, so that you can process further to remove the harmonics from the system. So this way you can use this block. I will going to show you this how it is made. So this is the filter, second order filter. So you can use these values here, frequency and damping ratio, and you can manage these blocks from the Simulink browser. And coming to the next point, that is a inverse PQ transformation, and it is goes to the, see this is here the mux, these two are called mux, and this is alpha, beta, and again this is a 0, and for this current also alpha, beta, and this is a 0 component, and which is going to connect it to the alpha, beta to again ABC, because ultimately for the PWM or any kind of controller which is required to compensation of the current and the voltage values, so it requires again in a three-phase system. So you can see here this blocks is again used to control the signals which is we have calculated before by this arrangement. Now this scope is connected here, and this is all our compensation signal that I'm going to show you that how it is going to work. And one more thing is connected here, that is a dq transform here. So this is the additional block, that this is the different thing actually. If you use the alpha, beta, so you don't have to worry about the dq, because it is a different theory and the different advantage of this block. And if you use the alpha, beta, so this have also different advantage and disadvantage that I already told you, that alpha, beta, that is a sinusoidal, that is a sinusoidal quantity which is converted into the two phase only, but the vectors and phasors are continued rotating. So that can be also explained by the program that I'm going to show you in this video also, that how it will be explainable to you, and what are the advantage of dq quantity also, that I'm going to explain to you. So I will show you this block. This is ABC to alpha, beta, and that signals goes to the dq, and here you can see the dq values. So this all arrangements are done here. So let me open the every value of the block, so you can design this simulation. See this line impedance, and this is non-linear load. I have designed the random snubber, diodes and bridge, and this is the inductive load here, RL load, and this is again the alpha, beta values. So this is all our the dq transformation here. So you see here, this is the matrix actually, and this matrix is help to design the alpha, beta and the dq values. So ultimately these two theories are depend on the two matrix, that is a KC and KP, Park transform matrix and the Clark transform matrix, and it is showing into the video, you can see here. And now let us start this simulation so we can understand this theory exactly. So this is the simulation, and it is done. Okay, now this is the complete running simulation. Now it is done here. So let me open first. This is the Simulink scope that is connected with the VABC and the current which is coming from the non-linear load. So let me open this, so you can see here the first graph shows the line voltage, that is a three phase. This is, we don't have any doubt on this. And this is the MW type non-linear current, and you guys know that when you connect the non-linear load across the three phase power supply, so it gets this type of the current into the system, and it causes the harmonics. So this is the line voltage and line current. So now move to the alpha, beta, and first step was the alpha, beta from the ABC. So let me open this block. So this is, guys, you can see here, this is the two phase, and the dotted black line you can see this becomes phase 0. It means now your three phase system is converted to the two phase system by this way, and this non-linear current is also become two phase from the three phase supply, as we see in earlier. Now how this is way is converted to the 3 phase to the 2 phase. I have show you. Now next is, after connecting this PQ calculation, so it goes to again the alpha beta over here, and the compensation values from the 3 individual voltage and the current, which is showing here. So let me open this. So this is the compensation voltage actually. So this graph is showing some error, like a difference between the actual or ideal voltage and the non-linear current. So this is the random values that will become from, or it will become from the difference between the ideal and the non-linear voltages. So this is the nearly to the 0 values, because the voltage doesn't affected by the non-linear load much more compared to the current. So let me open the current. So here you can see this is the compensated current here. So you can see this is the difference between, and it is much more deteriorated from the ideal voltage. You can see this is not anyhow the sinusoidal voltage or the current. Okay, now finally we will move to the compensation signal, that is very much required to generate the PWM signal for the controlling the active power filter or the shunt power filter. And these signals is look like this, and you are much more familiar with this type of signals in a theory or the book. Now this is the final compensation current, which is produced by the ideal voltage and the MW type non-linear current. So this signals is help you to design the PWM signal further to process the active power filter. And this is all about how to calculate the compensation signal for the non-linear load, and at the final you can process this signal to the PWM generation, so that you can also design your active power filter or the shunt power filter, UPQC, and the FACTS devices and many more things. So this is actual practical example for the alpha beta transformation, which is developed by the Clark transformation. And this is the dq remain the block. Again let me show you, this is the 3-phase power supply which we have connected the non-linear load, and the signals is need to be connected with the alpha beta block. This is nothing else, this is a matrix which is used to convert the alpha beta. So let me show you this alpha beta again also. This is the 2-phase, you can see, and the angle between this is a 90 degree. And next is this PLL block is connected. So it is necessary thing to connect this PLL values here, because ultimately the dq, it is a DC quantity and it needs to be a constant at every instantaneous point of the AC cycle. So the disadvantage you can say in a dq transformation, that is you need to connect compulsory PLL block to the system, so that you can maintain your dq values at the output. It is an important thing, and it is a not perfect theory without a PLL when you use the dq theory into the compensation network. So you can see this is the disadvantage. And in case of alpha beta, the disadvantage is this is the varying quantity, because it's still AC quantity only into the 2-phase. So ultimately you need to again design your controller with the instantaneous power theory using the PQ theory. So this is also comes in a disadvantage. Now let me show you the dq values. So as I told you that it converts into the DC power, so it shows me the 1 and 0 values like this way. So after all, this is the all transformation of ABC to alpha beta and dq0, which helps you to design the active power filter and many more devices like FACTS and UPQC. So one thing we need to design also the phasor for this, to understand that how the Park and Clark getting differentiate between each other. So I know these guys, it is very much complex system. This today videos is become much more complicated, that how is this system is used. So I have also programmed some files here in MATLAB, so it will help you to imagine that how the dq transformation is work. So this is the program files. This first files is 3-phase, and this is once it converted to alpha beta, and this is ABC to dq. So one by one I will going to show you this. So this is all about the program, and let me run this. So you guys, you can see here this 3-phase, R phase, Y phase and B phase is connected, and you can see the red final vector is rotated across these 3 vectors R, Y, B, and it is usual correct. And this is the nothing else 3-phase system which I have shown earlier into power system. And next, once this 3-phase system is converted to the alpha beta, it means, you guys, you have remember, for the simplicity I will show you again what is alpha beta. Alpha beta, it means 3-phase to 2-phase system. So let me show you this phasor diagram for this. So guys, you can see here this 2-phase, you can see here R phase and the B phase. So this is rotating vectors are associated with these 2 quantities only, not the 3-phase. Here you can see the 3rd phase is 0, and these 2 quantities only controlling the red line, and it shows the alpha and beta values here, and these 2 quantity alternating changing the values of this. So this is all about the alpha beta. Now this is still alpha beta is operated at the alternating quantity. So next is ABC to dq0 theory. So this program I am going to run this. So you can see the 2, this is the 3 ABC phase, and it converts to the dq. So this is the direct quantity and this is the quadrature, and the angle between them, that is a 90 degree. So this is called the DC magnitude, and it continues goes to the rotate because it operates on a DC values, and the angle between both, it always become 90 degree. So this is all operated at the DC values. So let me show you the final block which is connected over here. This is the final ones. This from is coming from the dq transformation, and this is ABC alpha beta, that lines is connected over here. So let me show you this also. So this is the final graph of our video, that is the first graph 3-phase system, and it needs to be connected or it converted to the 2-phase system. Here you can see. So this is the voltage signals, and you can see red line is 3rd phase is become 0 here. So first this 3-phase system converted to the 2-phase, and this is the dq. So you can see this is the DC quantity again, and the graphical representation I am going to show you here. You can see in a window that how 3-phase vector just now I have shown into the program. This works on this principle, that how the 3-phase system is going to convert it into the 2-phase and the DC values. So I told you that what are the advantages, that this first alpha beta have advantage that you can control only the 2-phase, and the measurement instruments are reduces, and the wiring is also going to reduces, because ultimately you can controlling the 2-phase, and 3rd phase is indirectly controlled by this alpha beta. And 3rd one, that is a dq theory, that is a field oriented control actually. So this associated with the DC supply, so PLL is a must, and this is also the accurate system that we use in many devices to control the compensation network. So thank you everybody. I hope you have understand this today's topic, Park and Clark theory. So guys, I am telling you that if you don't understood this any parameters or anything from the Park and Clark theory, so this is the new topic, so you can comment in our video, so I will try to reply your question. Thank you guys, thank you very much.